Okay, so really similar in this one. You're looking for the crisscross pattern that makes up the sine law. So, for example, I can go straight across to this side, and let's see here. So I have, do I have enough here to do that?
Yep.
So 4.8, and then, but I'm missing another length here.
You got a third angle. You got a.
Sorry, say it again?
You got to find the last angle.
Oh, thank you, yes. I'm not awake yet, even though it's 2:15. But let's see here. So, help me out. 129. Oh, what's that?
51.
51. Thank you. There we go. 51. Now we've got enough information. I was starting to think I made a mistake on my notes. So we can pick either side that we want. I'll pick this one. So if I'm looking for the missing side, which is s there, then I'll put s on top to make it easy to solve. So s divided by the sine of 89 equals, let's see here, 4.8 over the sine of 51. And if I rearrange that, let's see what we get for length of s. So 4.8 times the sine of 89 divided by the sine of 51. So it's roughly 6.2. Okay. And if we wanted to find the last length, again, I can make any pair. So the last one I'm looking for is r. So let's say r divided by the sine of 40 is equal to, I'll use the original ones again. So that will be 4.8 over the sine of 51. Any idea why I'd want to use the originals?
It's more accurate.
Yeah, no rounding in the original values, so it's more accurate if we do. So let's see where we're at now. So 4.8 sine of 40 and divided by the sine of 51. So I get about 4.0 for the length of r. Any questions so far? Cake? Okay. So, okay, so cosine law is a little trickier. Just a little bit longer in its formula. Basically what you get here is if you ignore this part of it, you get Pythagoras. Right? If you take this part out, those are Pythagoras rearranged. Now here's the crazy thing. Textbooks always do this. They always quote it as having 3 different formulas. But if you look, they're all exactly the same thing. It's just they've changed the letters around. So basically, you can say to yourself, it's not worth memorizing all 3 types because the formula says the same thing. Okay? So basically, the simplest way to think of this formula, because it is a longer one, is this part of it is Pythagoras. This part that you already know is Pythagoras. And since we're working with a triangle that is not a 90 degree or not a right triangle, there's a sort of a correction that the cosine law makes up. Okay? Yes?
Is it not really Pythagorean because you always add, like.
Sorry?
You always add the 2 squares.
Oh, I mean just this part is like Pythagoras right here.
Yeah.
A squared equals b squared plus c squared?
Yeah, I mean but for the next 2 it doesn't.
Oh, I see, but all I'm saying is it's just that, okay, whether you call your triangle A, B, or C, right? Here's one triangle. Let me try and draw it again, see if I can duplicate it. Okay, so let's say in this triangle it's A, B, C. You'd say A squared equals B squared plus C squared?
Yep.
But that's only because I chose to label it that way. Maybe I want this to be B, I want this to be A, and I want this to be C. So B squared equals A squared plus C squared, which is what it says underneath my scribble there. Right? So it's just all they've done is mix the letters of the triangle up. It's identical. It's not worth memorizing. So the first part is Pythagoras, which you already know, and this part is the little correction. So what do I mean by that? Well, if you imagine that this is the right triangle, okay, the cosine law is going to take up this extra piece here that's not normally in the triangle because it would be stopped here at 90 degrees. So I'm not going to derive the cosine law for you. It is a little bit trickier to do, but you're certainly capable of it. So this formula, same way that we had it before, the capital letters, see this is why I got it, this book must use it a different way. The capital letters in this one stand for the angle. Oh no, that was the same, that was the same. Okay, there we go. And the lowercase letters are for the sides. Okay. So it can be confusing because there's capital A and there's lower a and there's small b and anyways, let's just start using it and we'll see how it goes. Okay, this is one, it will appear on the formula sheet, so it's not worth memorizing it along with sine law, but you do need to have them handy for doing your homework and tests and quizzes and whatnot. Okay, so let's try the first one here. Triangle ABC, the measure of angle A is 35 degrees, and side B is 16, side C is 19. So basically everything here has been set up for us. Now, one thing you're going to have to start remembering, the sine law is things opposite. So sine law usually looks something like this if you draw the connections. If you draw the connections in cosine law to see, is this suitable for cosine law, you end up having both sides and the angle between them. Okay, so that's the pattern you're going to see that fits nicely into cosine, is you have both sides and the angle between. So this is the side that I'd be looking for. These are the pieces in a cosine law question. It is also possible when you have all three sides that we'd be using cosine law instead of sine law. Okay, so it's going to come down to, you have to make your decision, is this cosine law or sine law, when we get through these first couple examples. Okay, so this one is just a matter of filling in the formula, which is a squared is equal to 16 squared plus 19 squared minus 2 times 16 times 19 times the cosine of 35, the angle which is opposite. Okay, so I have, let's see here, a squared is about 119 according to my calculator. So if I take the square root, it's going to be about 10.9. Okay, so I'm going to get you to do this one by yourself, but you're going to have to do your labeling. And again, it would be worthwhile for you to draw the cosine law pattern. It is the sides that enclose the angle and the side which is opposite to the angle. Okay, so if I label these ones, angle C is down here, it's 40 degrees. And then it says side A. So if this is the angle, then directly across is side A. And then it says this is T. So directly across would be 20, would be side T. Okay, so that should be your labeling. And again, here's the cosine law pattern. This is as explicit as it gets to see what the pattern looks like. It's the sides that enclose an angle, and it'll be finding this angle which is here directly across. So let's take a look here. This time, that's C, so called little c. So c squared equals 20 squared plus 16 squared minus 2 times 20 times 16 times the cosine of 40 degrees, the angle across. Okay, so I end up with 165.7, and the square root is going to be the value for c. So 12.9. Okay.